Shall we start? Uh, am I audible? Okay, so hello everyone. Welcome to your first session in Aero Club Summer School. Uh, we are the Aero Club of C5. We basically like to play with drones and planes, and we are a group of people who have love for aviation, and we do various projects and various sessions and things like this in our club. Is my is my screen visible? Is my screen visible? Okay, so the first session would be on the basics of aerodynamics. So here we'll learn about all the terms which are associated with aerodynamics and all that mostly the mechanical part, all the forces that play a role in all the forces that play a role in making an airplane fly. So this would be just the basic terms, so everyone would be on the same page for the later sessions. Let's start. So these are some of the terms which we will be learning. We'll start with airfoils, then we'll go towards lift, then drag, and we'll end our session with Reynolds number. Okay, so our first term is airfoils. What are airfoils? One minute. Okay, sorry for the delay. We'll continue. So, as I said, these are all the terms we would be learning today. This is we'll start with airfoils, then we go towards lift, then drag and induced drag, then we'll end our session with Reynolds. So, what is an airfoil? This might be a term you have heard for the first time. So, let imagine a wing of an airplane, and if we make a cross section of the wing, we cut it in half. The shape which we see is basically called the airfoil. So, the cross section of the wing is called the airfoil. This airfoil, the shape of the airfoil plays a crucial role in governing the ways of light. Like the shape of the airfoil like manipulates the flow of air, and it creates lift or drag. Different shape of the airfoil are used for various purposes. Like the airfoil of a commercial flight is different from the airfoil of a supersonic flight. Some of the terms associated with airfoil. So here we can see in the diagram the leading edge. So basically the front edge of the airfoil is called the leading edge, and the rear edge of the airfoil is called the trailing edge. The leading edge, the line connecting the leading edge and the trailing edge, the straight line, is called the chord of the airfoil. Now, the camber, it is the camber is something which basically measures the curvature of the airfoil. So airfoil can have different curvatures, different the way they bend can be different ways again based on the usage of the airfoil. So camber can be positive, negative, or there would can be no camber for the airfoil. So now, angle of attack. What is the angle of attack? So when the airfoil passes through the air, if it makes a certain angle with the incoming flow of the air. So that certain angle is called angle of attack, and it also plays a crucial role in how much lift is generated. So what is lift? We'll get to know. It's basically but lift is basically the force which keeps the aircraft airborne. So this angle of attack uh, governs the how much lift is generated or how much drag is generated. Now, so the airfoil is basically designed to manipulate the flow of the air. Okay, so any questions regarding the terminology of the airfoil? Like any more terms? Does anyone want to know about? Yes, Chetna.
Um, will we get the notes of this and all?
Okay, I'll upload the slides in the Meet only in the Microsoft Teams somewhere after the end of it. Anyway, so is there a doubt? Okay, so we'll continue. Now we know the airfoil terminology. Now, like I said, airfoil is designed to manipulate the flow of air around it. When it does manipulate the flow, there are some pressure variations which are formed around it. Why are these formed? We'll learn a bit later. But these pressure variations do create something called a center of pressure. So if we take all the pressure, all the different pressures on the airfoil surfaces, and we multiply them with the corresponding area which the pressure is formed, we'll get the net force. That net force we'll get the position of the net force can be found by basically just doing sigma m equal to 0, which equal to all the moment if we equate it to 0, the net we will be able to find the position of the net force. That position of the net force is called center of pressure. This here in this around at this point, the movement remains constant regardless of the angle of attack. So even if the airfoil moves up or down, the movement around that point would always remain constant. But it is there's a catch. It is only valid for constant and low velocity. It won't be valid if the velocity is changing constantly. And for in general, if the velocity is very low, the center of pressure can be found at the one-fourth way of the chord line. If the velocity is low and constant, and if the velocity is supersonic, it's generally at the halfway through the chord line of the airfoil. Any questions? Okay, I'll be moving on. So this is just a general introduction of the airfoil. We'll know more about them. So what you might have already seen the slide, but what are the forces that all act when airplane is cruising through the air? All the forces that act on the airplane can be resolved into four categories. So those forces are drag, which acts uh, opposite to the motion of the airfoil; thrust, which acts at the direction of the motion of the airfoil, which are created by engines and propellers; lift, which helps the aircraft to remain airborne. The It is one of the more crucial forces, and weight, which is just the weight of the aircraft. But it also the weight is also very important to take into consideration. These are the definitions of those terms. So the lift is basically the force which is generated. Mostly, it is generated by most of the aircraft, but most of the lift is generated by the wings of the aircraft. Weight is just a gravitational force. Drag is the force that acts opposite to the aircraft. You can think of it as an air resistance, but it's not really that. I'll get to that in one later, a bit later. And thrust is which propels the aircraft forward. It is like generated by engine or propellers. In engine, we know the combustion process happens, and we might have learned in previous classes. The combustion process creates thrust, and it propels the aircraft forwards. So today we'll be mostly focusing on lift and drag. So before we move towards lift, are there any questions? It's Lohita 301206.
Can you explain the aerodynamic center part again?
Okay, So look, here there are around an airfoil, there are certain pressure variations. These lines, these all blue lines are the differences in pressure, which are around the airfoil. So using pressure, we can find force, which is pressure into area. So if we multiply the pressure with the corresponding area, we'll get the corresponding force. And if we do a delta F equal to 0, we can find the resultant force also. So result, this resultant force will have a resultant position. Like if we do delta M equal to 0, we can find the place where the uh, position of the resultant force is. That position is called the center of pressure. Why is it called the center of pressure? If we find the movement of all the forces in that point, the moment would remain constant regardless of the angle of attack. Even if we move the airfoil upwards or downwards, the pressure variation would be perpendicular to it. And if we find the movement around that point, it would never change. It would remain constant. But it is only valid for constant and low velocity. If there are not much variations in velocity, then only it's valid. If and for Let's if like in general, if we calculate it in general, for constant and low velocity, the chord line, the center of pressure would be in one-fourth way of the chord line for low velocity. And if the velocity is supersonic, which is like higher than the speed of sound, again, in general, the chord line the center of pressure would be halfway through the chord line. But I'm just giving it as information. It is always better to calculate it by the way from the way I said, like find the resultant force and find the position of the resultant force. That position is the center of pressure. Is it clear? Okay. Is it clear, Lavanya?
Yeah, got it. Thanks.
Um, yes, 21 as the
Rajesh,
ones.
hi,
Okay.
hi Apsana. Apsana, can you
Hi.
enable this either a chat or the mic? Mic is disturbance. I understand that. But can you enable the chat for us? That way we can ask a doubt between also.
Okay. Is it not enabled?
Only channels moderator can post in this channel. That's a message for us.
Let me see. Okay. Is it enabled? I think I have.
No, no, still not, Apsana. Still showing me the same message.
Okay, I'll do something about it.
Maybe you can ask the team to deal with it and you may
Yeah,
continue the present. Yeah.
yeah, I've asked them. They'll do something. Okay, I think it's unable. Someone asked me a question. Okay, so camber, right? Okay, so camber is basically just the curvature of the airplane. Like if we this dotted line right here is called the camber. If we make a line through the curves of the airplane, uh, that would be called camber. So the camber can be curved upwards, which means it's positive camber airfoil. The camber can be curved and the same line as the chord line. That means the camber of the airfoil is zero. If the camber is bit downwards, it's called the negative camber of the airfoil. So the camber different. All these different kinds of camber have different um, uh, applications. Like some are the for the zero camber, it is used in helicopter propellers and positive negative. All these cambers have their role. We'll know more about camber a bit later while we're learning lift. So yeah, no more questions, right? Okay, so okay, we'll take some more questions later. Let me continue. So, we will be starting with lift. Lift is a very crucial force of aircraft as it helps the aircraft to remain airborne. So how is this lift generated? It's the lift is generated by all the objects which basically move through the air. It doesn't have to be just aircraft. It is also generated in the camber of the motor vehicles, and it is the force generated when a solid object courses through the air, right? So it acts through the center of pressure, and it acts always perpendicular to the direction of flow. How is it generated? When an aircraft flies through the air, there is a pressure gradient created around it. This pressure difference is what causes lift. So when in the above of the airfoil, the pressure is
Excuse me, Upasana.
yes.
Can you remind them about the attendance we are going to take now?
Yes, so we're taking attendance right now. The
Yeah,
name,
let's just show them the QR code.
yes, here's the QR code. You can scan it and give your attendance. I'll give you 5 minutes. The form would be closed on 11:15. So
We are not able to see the QR code.
No,
okay,
the QR code will be posted, but in the chat box, the link is given. So till that, you can fill it there. Can you open the QR code from? Wait a minute.
uh, shall I send it in the chat?
Okay.
Okay, I've sent the QR code in the chat also, and link is also there. Bipul, do you have any question? Is it visible now in my screen? The QR code.
Excuse me, Upsana.
Yes.
Uh, Upsana, can you give me the overview of this summer camp, the topic we're gonna cover? So can you give us the flow chart or the overview of something so it
Okay.
will be
So
helpful to.
the overview is basically in the website, but I'll let you know. So the first, I'll start with the basics of aerodynamics, which I'm doing right now. Then we'll design a airplane using Fusion 360. Then we'll go on to analyze an airfoil in Excel FR5, and that would be the aero modeling part. And for ideal robotics, there would be some gazebo simulation and all that. You can see it in the C5 website, detailed overview of the summer school.
Okay, thank you for that.
So guys, we will be closing the Google form. So anyone who is left, please fill it. Also, there will be one more Google form which you need to fill to avail the attendance for this lecture. So you need attendance in both the Google forms. That form also be randomly spammed here, so the timing is not fixed.
Okay, so I will be moving on. Meanwhile, you can fill the form if you haven't already.
Hello. Okay, one more
Hello.
minute for your attendance, okay? One more
Okay.
minute for attendance. Please mark it fast.
Guys, 5 minutes is pretty much enough for you to fill the attendance. There is only 3 fields which you need to fill. So it shouldn't happen that you're asking the form again.
Okay, I'm closing the forms now.
Shall we move on? So, so we were talking about how lift is generated. Like I said earlier, when an airfoil moves through the air, it creates a pressure gradient around it. This is you can see the profile around here. These lines are the differences in pressure around the airfoil. So the pressure above the airfoil is lower than the pressure below the airfoil. This is this difference in pressure causes a force, resultant force which is called lift. But where does this pressure distribution come from? There are many much debate about this. Like people are still not clear about this, and there are various explanations. Those explanations can be categorized into two groups, which is Bernoulli's equation explanation and Newton's law explanation. It's broadly classified into two groups. Let's get into Bernoulli's equation explanation of how lift is generated. So we know all know Bernoulli's principle. This is the equation is right here. It's basically the conservation of energy equation. Uh, so in above the airfoil, the air goes through high speed. The shape of the airfoil is like that. Both the particle above and below should reach the end of the airfoil at the same time, right? So above the airfoil, the particle has to travel a greater distance to reach the point at the end of the trailing edge of the airfoil. So the speed of the airfoil above is higher than the speed of the air particle above is higher than the speed of the air particle below. And we know, according to the Bernoulli's equation, if the speed of the particle is high, the pressure would be low. And if the speed of the particle is low, the pressure would be high because pressure and this equation needs to remain constant. So that's why the fluid above is at lower pressure than the fluid below. And this difference in pressure will create a resultant force in the upward direction, and that force is called lift. But there is a small catch. Can anyone tell me what it is? If you have read Bernoulli's principle. And anyone, it's fine if it's wrong. You can write it in the chat. Like, remember where we used the Bernoulli's equation. What were the conditions in which we could use Bernoulli's equation? Mm, Okay, Shilvas, Senthil, do you have anything to say?
Streamline flow should be there.
Sorry?
Then there be a streamlined flow so that we can apply Bernoulli's theorem.
Yeah, the flow. Yes, you're right, basically. So the flow needs to be streamlined to apply Bernoulli's principle, but this and the flow and Bernoulli's principle is used. this flow here is not streamlined, right? These are two separate flows. Here, so we can't apply Bernoulli's principle here, but it does provide a like good enough explanation that we carry on with. So are there any questions? You can use the Q&A or you can raise your hand. If not, I'll be moving on. Okay. Okay. So I'll be moving on. I wasn't able to see the chat before, sorry. So now I'll take questions from the chat also. So someone was asking why the particles above and below need to reach the end at the same time. It's because that the flow needs to be like the full flow needs to be single flow. It's if we the flow can't be separated. If we separate the flow, there would be some uh, like you can say weight behind it. So that's one of the assumption of the Bernoulli's principle that the flow is laminar. Here we have taken the for the explanation. Okay. Um, so we'll be moving on to another explanation which can be given as Newton's third law. So when an airfoil passes through the air, it creates a curve of the it creates curves. It curves the air around it. That curve creates a downward through the air. So in order to create this curve around the airfoil, the airfoil must be applying a force to create this downward. So if the airfoil is applying a force, so there would be an equal and opposite reaction that so the air must also be applying an equal and opposite reaction to the airfoil. That reaction is basically lift. So this is the Newton's third law. explanation. We can also think of it as the airfoil is deflecting the air particles in the opposite direction to it. When the air particles collide with it, the airfoils are deflecting it. So the air particles are also applying an equal and opposite force on the airfoil and keeping it airborne. That force is called lift. So these are the two major explanations. There are more explanation there, but there is still much debate about how exactly it's created. Because all these things happen simultaneously. It's not like first the air particle goes and then it comes back, then the force is created. So this downwash and upwash, this happens simultaneously with the creation of production of lift. So, so we don't fully know what happened, but there are good enough explanations for the production of lift. So this is just a general equation of lift which we can apply when all the values used are most not changing that much. So lift is equal to CL. CL is called the coefficient of lift. We'll be learning more in the later another session. This coefficient depends on various complex variables. So all that complex variable which lift depends on has been uh, clumped into a single coefficient of lift. And this coefficient lift is not constant. It depends on various factors also. So that we'll be learning more in later session. And the rho is the density of the air. Velocity is the velocity of the object, which is square. And area is the area. Here it's written wing area, but it's basically the area through which the air, which is in the contact with the air. So the entire area needs to be taken. So again, this is the general formula, and it depends on various factors. Mainly, the coefficient of lift is a bit complex than a simple coefficient, I'd say. Any questions? The chat or Q&A, you can use. It's the density of the air. Density in the equation is the density of the air. Yes, so this formula is it's derived from the Bernoulli's equation only. Again, I said this like this you'll learn more about in the later sessions. But yeah, if we just use the Bernoulli's equation and put force equal to pressure into area, and we just rearrange some things. Again, the coefficient of lift is a complex, like it's not a simple constant, a simple coefficient. It's all the complex variables which associate lift, which affect lift, are clumped together in a single coefficient. This is the coefficient of lift. Any more? Okay, I'll do. See, like here also you can see this v square rho v square by 2. It appears here also in the Bernoulli's equation, and it appears here. So it's derived. You can say it's derived from Bernoulli's principle only. Now, so coefficient of lift, there is a, you can say, kind linear dependence of coefficient of lift, angle of attack, and coefficient of lift. So if the more we increase the angle of attack, the more downwash is created and the more air is deflected. So the velocity of the air particle above velocity of the air particle above the airfoil, it's increased even more. That's where the pressure or gradient increases even more, and the pressure above the airfoil decreases even more. So that creates more lift. But there is something called a critical angle of attack. So that point, also called the stall angle of attack. Beyond that point, lift, if we increase the angle of attack, the lift would not increase, but it would decrease drastically, and the drag would increase. So why is that? You can see in this picture, if we increase the angle of attack too much, the flow will become like the flow won't be able to attach to the surface of the airfoil. It will become detached and create a wake behind it. So that wake will decrease the lift significantly and create more drag, and which is very dangerous for the aircraft to have like suddenly happen that. So there should be a critical angle of attack, and the aircraft should not, the airport should not exceed that. The lift can also be increased by increasing the camber. So by changing the camber of the airfoil, more deflection can be created. So there would be larger pressure difference. So here we can see that if there is zero camber, there would be no lift at zero angle of attack. There would be zero lift. If and if there's a positive, there and negative camber, this is how it will react. But yeah, like every airfoil will have a critical angle of attack. Beyond that, the airfoil should not the angle of attack should not exceed that, or else there would be instability in the airfoil. Any questions?
Uh, can you explain how lift increases when camber is increased?
Okay, so see, if we increase the camber of the lift, the curvature of camber of the airfoil, the curvature of the airfoil increases. So if the curvature increases, the more air would be deflected around the airfoil. This more deflection would cause an increase in velocity so the airfoil remains let's say constant laminar. So this increase in velocity will further reduce the pressure. So that there would be a more pressure difference around the airfoil, and that pressure difference will lead to more lift force being generated. Is it okay? The more bent the airfoil is, the more the more bent the airflow would be, right? Because the airflow will pass through the surface of the airfoil. So if the airflow is more bent, it needs to travel a greater distance. So it needs to have a higher velocity. So, and if it has higher velocity, according to Bernoulli's principle, it will have a lower pressure, even lower pressure. So the lower pressure would create an even more difference of pressure, and that the difference, as the difference would increase, more lift force would be generated. Okay. Is that okay? Any more questions? You can ask in the chat and or Q&A. Okay. I'll move on then. Okay. So this is all about lift force, which how it gets affected by the different design of the uh, airfoil. How so we can use all these factors to make a desired airfoil to for our aircraft. So uh, we may want a high critical uh, so we can't increase the camber of the airfoil too much. That would lead to like instability and like that. Some it will create problem in maneuvering and all that. So we need to adjust our airfoil accordingly. How much lift we require? Like, is it required to have a too high critical angle or too low? Critical angle, like they usually for commercial planes, you can say they usually remain between these like 10 to 15 degrees only. So if we're building anything else, then we need to customize our airfoil accordingly. So that's all about lift. So now drag. Like I said, drag is the resistance for like faced by the airfoil, resistance of the air. It acts opposite to the flow of the airfoil, and it's like friction. It like reduces the efficiency of airfoil, leads to more fuel consumption. So uh, drag is basically the air resistance. Yeah, so how is it generated? You can say it's generated by the interaction of the object with the fluid. When the fluid and object are in relative motion, there should be a relative velocity among them. Then a force is generated between a mechanical force, which is called drag. And this force is mechanical, so there needs to be contact. If there is no contact, there won't be any drag. And if there is no difference in velocity or there's no related motion between them, then the drag would also not be generated. So here we can see that every aircraft will have some drag. So there are some ways to reduce this drag. Like uh, we can use various ways. Like there is a we can create create such structures to manipulate the flow of air modes to pass it through the airfoil. Okay. Now, like I said, that there are pressure differences between the in the lower region of the airfoil and the higher region of the airfoil. So this pressure difference, when the airfoil is moving at a faster rate, so here the air particles at the high pressure would like to move to the lower pressure region. So the air would like to go from high pressure region to low pressure region. This will create a curl like this will create a curl around the wing, and that curl and the pressure would go to the lower pressure. Then it would come down to higher. Then the higher pressure would we keep going upwards towards the lower pressure. This curl is basically called wingtip vortices. Uh, and this wingtip, and if the air is humid enough, we would be able to see these vortices. Uh, like you might have seen the trails left behind by jet planes and all. Those are basically the wingtip vortices. Any questions? Okay. So, like I've said before, that if there is an airfoil, there yeah, like I've said before, if there is an airfoil, there would be a pressure difference around it. And we have also learned that this pressure difference below the airfoil, it is higher pressure, and below above the airfoil, it's lower pressure. So, the air particles would like to go from high pressure area to low pressure area to, like water comes from higher potential to lower potential. Water always flows from higher potential to lower potential. These air particles would also like to go from high pressure region to low pressure region. So they will basically leak out around the edge of the wing. At the tip of the wings, they leak out in a curled manner. There would be curls formed around the wing. These curls are called wingtip vortices. And these vortices are, you can think of it as like trail of spirals going from emerging from the tip of the wing. And also, if the air is humid enough, these vortices would be visible, and you might have seen them also. Like when a jet goes above there and it leaves a trail, that's not smoke or gas, that's the vortices. Is it clear? The wing is placed upwards. It's basically for stability and control surfaces. That's a topic. Um, I haven't covered it. Maybe I will cover in a later session. Let's see. Uh, yeah. So Chitra, yes. So the thing is, I just want to go from a higher potential level to lower potential level. Yeah, you can also say they're going to fill in the gap created by in the low pressure region by through the high pressure region. It's like the nature of the fluid, right? It will always try to go from high potential to lower potential. Like water comes from higher region to lower region. Same way here it's in the air. It will try to move from lower potential pressure to high potential pressure. Yeah, so yeah, that was Mohit, that was basically what how lift is generated, right? Because there is a higher pressure in the below of the airfoil than the lower, and above the airfoil, there is a lower pressure. So it's like think of it like a straw. If you suck on it, there would be a low pressure region inside the straw, and the fluid will come towards the straw, right? Fluid would be pushed into the straw. That's how lift was generated, and this also the how wingtip vortices are created. If the air is humid enough, then the wingtip vortices would be visible. Like maybe at the higher altitude, there are more clouds, or if there's more water level humidity in the air, then it would be visible. Yes, so yeah, the velocity needs to be high enough for in order to create these vortices. Like you the vortices you will see like vortices will be visible when the jet plane flies through compared to when commercial airplanes fly through. Um, Again, those are all the like different intricacies. Like that's basically according to a requirement, the designs are made. Again, I wanted to talk about like stabilities and all, but I'll see in later session, the last session. No more questions, right? Yeah, so yeah, I'll be just talking about how what is this like induced drag. So yeah, this two slides away. Just asking if there I haven't asked for doubts yet, so I was just waiting for doubts. Okay, okay, so I'll do one. I'll take more questions later. So what is the consequence of this wingtip vortex? So this wingtip vortex creates something called a downwash. So see, this vortices, here the vortices are moving in the clockwise direction, and other side it's moving in an anti-clockwise direction. So the air is basically pushed downwards than it was. This downwards, which we can see, the push downwards air is called downwash. This vortices push the air from the in the front of the airplane downwards, and this is called downwash. What is the consequence of this downwash? We'll see. So now for the effective airflow, the relative airflow was like this, but now the wingtip vortices have put that downwards and create a downward. So now the effective airflow has has tilted a little bit, and this by angle of epsilon. This epsilon is called induced downwash angle. So, like I've said, the lift should be perpendicular to the flow of air, right? And it should, I said earlier. Now the effective lift would uh, tilt a bit by angle of epsilon, and this effective lift will contribute a bit if we resolve it through the original shape of the airfoil. This if it will create something called a induced drag. So if we resolve it here and here, then it will contribute more to the drag. Um, this drag is called induced drag, and this induced drag is caused by lift itself. Yeah. So questions and any questions? Okay, so pressure drag and friction drag are the drag which already exists. Like this vortices create induced drag, which is a drag created by lift. Pressure drag and friction drag they already exist when the air airfoil passes through the air. The pressure drag happens due to shear stress and all. So it shifted because see here the air was pushed downwards by the wingtip vortices. Uh, if the air, let's assume there was no vortex and the air was supposed to go something along the line, but now there is a vortex moving around inwards into the airplane. This vortex will push the vortex is basically air, right? Air particles moving inside. So that vortex, these air particles will be pushed downwards from where they originally were. This downwards push will shift the relative airflow. Will also shift the relative airflow was in this line, but the downwards will shift it bit downwards by angle of epsilon, and the effective airflow, which would be faced by the airfoil, is this. Uh, this would be pushed by the epsilon, and because of that, lift should always always acts perpendicular to the relative airflow. The lift will also shift by the same angle epsilon. But if we resolve it around the original lift through the airfoil, we'll see that there is a small component of drag which is induced in the direction of the original drag. So induced drag is a drag which is created by lift itself. Okay, so turning is it's something called control surfaces, and those are present in the front wings and the tail wings of the aircraft. Vortices are just phenomena which cause when an airplane, like natural phenomena which is caused when the airfoil passes through the air at a high speed. Size of the airfoil, I don't really think so. It depends on the size of the airfoil, but uh, let me confirm. Okay, so the induced drag, it it is it depends on it is inverse. It has an inverse relation with the wingspan or the aspect ratio. You can say aspect ratio is basically the wingspan by the length of the wingspan and length of the chord. So it has the inverse relation with the wingspan. See, again, like it depends on inverse of the wingspan, right? So we can increase the wingspan to decrease the induced drag in the airfoil. Yes, not the airfoil, but the wingspan, you can say. The entire, yes, you can wingspan by chord length. So yeah, it also depends on the size of the airfoil. We also like use in the commercial aircraft and tactical aircraft, we use many control surfaces to change the shape of the airfoil and increase lift, reduce lift. So those can also be used to decrease the induced drag. Any more questions? Okay, so I'll be moving to the last part of today's session, which is Reynolds number. So, for in order to create an aircraft, it is really important to determine the nature of the flow of the air, right? Before the testing of the aircraft includes like just testing them in wind tunnels and all. So this Reynolds number is something that helps us with that. It was like Osborne Reynolds use the Reynolds number to classify the flow of the air into two types, laminar flow and uh, turbulent flow. So, what is the Reynolds number? So, it is, uh, you can say Reynolds number is the measure of the effective viscosity of flow, not the actual viscosity, but the viscosity which is felt when an object is moving through the air. So, this is the formula for Reynolds number. Here, are equal to rho v by L by mu. So what is mu is dynamic viscosity of the fluid. What is the what is dynamic viscosity of fluid? So this is the resistance, the viscosity felt by fluid by one layer of fluid to the other. So when two layers of fluid are passing through each other, the friction, the resistance which is felt by them is called the dynamic viscosity of fluid. And this the kinematic viscosity of fluid, it is similar to dynamic viscosity, but it is the resistance felt by the fluid when it's flowing through an external force like gravitation. So you can say the dynamic viscosity is the internal resistance of the fluid, and the kinematic viscosity is the resistance felt by the fluid when it's flowing through an external force. So any questions? Turbulence modeling, I don't know really. I'll confirm with the with my team. Yes, I'll go to that later. Um, there's no doubt till here, right? See, the Reynolds number. When we are testing the aircraft through a wind tunnel is basically a tunnel where you can put the aircraft to various condition of the wind and test how it holds up. Right? We need something to classify the like type of wind basically that flows through it. So that's why we need Reynolds number to classify the flow of the fluid um, in which our object is moving. Any more questions? There is a wind tunnel at IITM. Like in the AM department, like applied mechanics department, there is a wind tunnel. Yes, I am. Okay. So I'll yeah, we are actually in like our club. Some people are actually working on a drone that can both fly in the air and swim in water. It's a project that some people are working on. So I think yeah, it's possible. Let's see if they would be able to make it. Okay. So I'll be moving on with it. So we can use this Reynolds number to classify the flow into two types. One of them is called laminar flow, and one of them is called turbulent flow. And it often occurs at the same time, doesn't have to occur individually. So, what is laminar flow? It is a flow where the viscous forces are dominant in this flow, and the flow acts parallel to it. And all the parameters like velocity and all, those are predictable and easy to measure. For the flow to be a laminar flow, we can put all the values in the formula, and it would usually be in the range of less than 10 to the power 3. So if we find the Reynolds number as less than 10 to the power 3, then the flow is the laminar flow. Okay, I think the attendance is clear. I'll again give you 5 minutes to mark your attendance. Here's the QR code for I'll share the QR code for this attendance.
You can mark your attendance in the link also. It's given in the chat. Please mark before 12:15.
The attendance will be considered only if it's marked in both the Google Forms.
Okay, I'll be closing the forms now. And there were many doubts regarding the software that we are using. So you can check our channels we have made for different sessions. In that you will find the resources and software that we are going to use for another sessions. Just install the prerequisites beforehand. Okay.
Okay, so I'll be continuing now. This is a little bit of the topic is left. So again, if the Reynolds number is less than 10 to the power of 3, then the flow is considered to be laminar flow. And in this flow, the flow is uh, dominated by viscous forces. And the flow is parallel, and all the parameters like velocity and pressure is predictable. It can be calculated easily. But if we find the Reynolds number to be more than 10 to the power 4, then that flow would be called turbulent flow. Or in this flow, the inertial forces would be dominant. So, what do you mean by viscous forces are dominant? Viscous forces are dominant means like the flow would there would be viscosity within the flow, right? There it won't it it would be less more predictable. Like um there won't be much disorder in this flow. It's all going to be parallel, but inertial flow are dominant. So it would like if the flow is are a bit unpredictable. There would be curls like this, which happens in the flow, and this flow is called turbulent flow. And here the inertial forces are dominant, and the Reynolds number is more than 10 to the power 4. So this is basically the use of Reynolds number. Um, and yeah, in turbulent flow, the parameters are a bit unpredictable. Like they can be calculated, but they are complex to calculate. So there are many factors that needs to be taken into account to calculate the parameters in turbulent flow. So with this, I'm done with this session. Any questions till now or in this topic? I'll wait for 10 to 15 minutes, 10 minutes. Like again, it's a range, right? Like if it's between 10 power 3 and 10 power 4, like we're just defining certain characteristics for it. Like if there's not some less than that, then if pi flow is something, I guess you won't be finding in aerodynamics. It's basically if there's an internal flow within a pipe-like substance or cylindrical substance, that flow will have a certain characteristics. like you can, the velocity is uniform because there is no viscosity, right? Because viscous forces are not dominant. There won't be much uh, what resistance between the air particles, so they can move. And also the air particles are inertial. So it's more uniform velocity distribution in turbulent flow. You can also say in turbulent flow there is um, mixing of air around here. So that's also positive for the velocity to uniform be uniform around it. Yeah, if you don't have any questions and if you have filled the attendance, then you can leave. Before leaving, wait a minute. I'll I'll confirm. Uh, the link I'll maybe upload it in the Microsoft Teams only. Yes. Yes, only if I've attended 80% of the classes in the distance certificate. Uh, yes, Karthik, you have it down.
Um, yes, is my voice audible or is there any disturbance? Should I turn off the fan?
It's audible.
Yeah. So I'm really new to all of these things, and this kind of felt like an information overload because I'm learning all these. Definitely, it was relatable here and there, like the Bernoulli's principle and all that. Is there any resources or anything that we can, further look into to get better understanding so that we get more familiarized and used to these things?
Um, yeah, maybe I'll send you some link for YouTube videos. Like those really help me. Or
Oh,
like
okay.
some videos you can watch.
Yeah. Yes. Yeah. Thank you.
Okay.
And is it possible to have a discussion group where we can, discuss our doubts and stuff? I know that we have a channel, but it would be really nice if we had a discussion group where we can discuss doubts and stuff.
Over at WhatsApp.
Yeah.
Okay. I'll talk to people and I'll let you know.
Thank you.
we'll make a separate game for just the participants and this doubts.
Yeah, thank you.
Okay, yeah. If you have any question, you can ask or you can leave now. Class is over. Yes, there will be an assignment. It will be uploaded and you need to submit it, I guess, before the end of all the sessions. You have to submit it. And it's mandatory to submit all the assignments. So thank you. Yes, I'll share the PPT. I guess it will be uploaded in Teams only, all the assignments and all the resources and information. Just wait for a few minutes. And we'll talk it through.